Now, before we continue on with Series 3 and talking about units and the equal sign, I wanted to talk about something I mentioned in the previous update, which was what I was really going to cover in this series, until I came into the realization that, I had to talk about the equal sign in units before I could continue on with that information. And what I was going to talk about initially in Series 3 was more about 0 and infinity. Now, I did a 4-minute, 5-minute little introduction video in Series 1 about 0 and infinity, and I was going to expand on that a lot more. But when I was laying out the work and thinking about the videos, what I was going to shoot, when I went down one of the branches where I was trying to compare the smallest thing we've been able to measure in the universe, which is elementary particles, which is what we believe all matter to be made out of, and comparing it to the biggest thing that we've been able to measure in the universe. Some would argue the largest thing that we've been able to measure in the universe or observe in the universe, which is black holes. When I went into the extremes, thinking about 0 and infinity, thinking about the smallest particle in the universe and the biggest thing in the universe, I hit a snag, and it turned into a realization where when I brought in Robert Anton Wilson's maybe logic. And the snag was basically this: elementary particles have 3 properties. It's spin, force, charge, and mass. Black holes have 3 properties: spin, force, charge, and mass. Now, the only way for us to be able to say if something is a black hole or elementary particle, distinguish between it, is their masses. Because, again, they have the same, they could have the same spin, they could have the same force charge, but if one is the biggest thing in the universe and one is the smallest thing in the universe, then their masses would be different, right? This part is the snag. Based on general relativity, there is no size limit to a black hole. Well, some people say there's an upper size limit, and I think I read an article that said, there's an upper size limit to black holes, but there is no lower size limit to black holes. I don't know about the upper limit either, but there is no lower. I guess the upper limit would be mass of the universe, but there is no lower bound of how small a black hole could be, right? So if we take their properties and say elementary particles have 3 properties: spin, force, charge, and mass. Black holes have 3 properties: spin, force, charge, and mass. Then if we take a black hole, the largest thing in the universe, and reduce it to the same mass as the smallest thing in the universe, how are we to tell the difference between them? How are we to tell that one is an elementary particle and one is a black hole? And that's where I hit the snag, where I realized the equal sign is not an absolute. It's based on what it is that we're talking about, and that is units. So that's when I decided to make a series about the equal sign. I came into the realization that literally the most important symbol in the language of mathematics is the equal sign. And one of the most important things we should always keep in mind is what it is that we're talking about, which is units. Now, what I'm going to do is I found a little outcrop here. Hopefully, it's got a lot of jags on it. It's it's not as flat as I like it, but let's lay out a visual on this so it makes more sense. And hopefully, this is sort of a teaser on what we're going to get into when we start talking about 0 and infinity, and some of the things that made me grasp what 0 and infinity really meant for us. And which is 0 and infinity, basically talking about them is huge, is brilliant, because no matter what philosophy you follow, no matter what religion you follow, no matter what religion you do not follow, no matter what you believe, everything and nothing, they mean something to you. The concepts are huge. It incorporates everything. So it's quite important to talk about this. And mathematics, the language of mathematics, offers a certain unique perspective into 0 and infinity, and has allowed us to think about the boundaries of what we know, the limits of what we know, and possibly, some would argue, the limits of what we can know.